than the method was for tangent. Tangent, we just take the table of values and we reciprocate all the outputs. This one, you do the same thing, but there's a kind of a quicker way visually to do it. Cosecant is the same as 1 over sine. So when we graph this, we're actually going to sketch lightly the graph of sine x, which is just a parent graph, and we're going to use it as a guide. So I'm just going to sketch my graph, label and scale 0, pi, and 2 pi, and then going the other direction, negative pi and negative 2 pi. And I'm going to use my sine graph as a guide. So very lightly, I'm going to sketch in my sine graph. That's just my sine parent graph from 0 to 2 pi. And then you can extend it backwards as well, just so we do this from negative 2 pi to 2 pi. That's not actually part of our graph. This is just going to be used as a guide. So you might do that much later, or you might erase it when we're done here. But at the end of the day, all of these sine values are going to get reciprocated. So what happens when you reciprocate a 0? An asymptote, right? So any place where there's a 0, we're going to throw in asymptotes. So we have a lot of them. And then we'll just focus in between 0 and pi for a minute. This one has an output of 1. What's the reciprocal of 1? Still 1. So that point is going to remain there. If we take a teeny tiny number like, well, we'll start with a half. At some point, this is crossing a y coordinate of a half. What's the reciprocal of a half? 2. So this point-ish is going to bounce up to 2. What about something that's even smaller, like an 1/8? When you reciprocate a 1/8 y value, what's the reciprocal of 1/8? 8. So it's going to be, way up here at some point. And then as this comes back down on the sine graph, you're going to pass a half again, which will reciprocate to 1/2. And you're going to pass 1/8 again on the way down, which will reciprocate to 8. So your resulting graph ends up looking something like that. Which, how would you visually describe that so you don't have to think it through every time? It's a parabola that almost like got reflected off of the maximum, right? And you're just going to do that in every section. So here, the y value of -1 is still going to be -1, and then we're just going to kind of almost like reflect it over. So all your minimums kind of get reflected into parabolas, and those parabolas have to stay between the asymptotes, which makes sense, because as you approach vertical asymptotes, your graph should be going towards infinity or negative infinity, and it's just this. So that sine graph that we originally did is just a guide for its reciprocal cosecant. Your actual graph is just a series of little mini parabolas opening up, opening down, opening up, opening down, and so on. Does that make sense? Okay? For secant, we're going to do the same thing using cosine as our guide, because secant is the same as 1 over cosine. So your cosine curve, if I scale this pi to 2 pi, negative pi to negative 2 pi, your cosine graph starts at +1, ends at +1, and has halfway points at pi. So again, this is just my cosine graph that I will eventually be erasing. And I'm going to bring it backwards to 2 pi also. And so for both of these, your zeros turn into asymptotes. So any place on this graph that we have a 0, throw in an asymptote. Oops. And then you reflect the graph off of maxes and mins. And I'm not going to show you why again, but it's because of that reciprocal stuff. So this one here will flip down. This one will flip up, down. Now this one's a little different because on the outer parts we only have like a half of it. So this will eventually be a maximum. If you want to go slightly further than 2 pi, you can then bounce it. And on this one, if you want to go slightly further than negative 2 pi, just so that you can fully bounce it, that's going to give you another asymptote on either end. And then erase the cosine guide that was in the middle. So again, series of parabolas opening up, opening down. The main difference, if you're just looking at it, is that the secant one, which is the 1 over cosine, is symmetrical to the y-axis. That parabola in the middle straddles the the y-axis. So it's symmetrical to the y-axis on either side. Whereas the cosecant one, the sine one, just to the right of the y-axis it opens up, and just to the left it opens down. It's not a line of symmetry anymore. Simple? Okay, so that's what happens to all of those numbers when you reciprocate them, is that's really the image that you get. So that's your reciprocal functions. That's very different than the way we did the tangent one. The tangent one, you can't really work that way because this happened. Zeros became asymptotes. That definitely happened. But things didn't really reflect, if you look back. See, your zeros became asymptotes, and your asymptotes became zeros. But there were no maxes and mins to flip over. So with tangent, it was a little different. The tangent graphs always increase, and then once you come up with your new asymptotes, your cotangent graphs always decrease. That's what you have to remember for that. Okay? All right. Inverse functions on the back. So in Mrs. Fraser's notes, she goes from negative 2 pi to 2 pi, which I'm going to change that. I don't think that's the part of the sine graph we want to focus on. We want to focus on a part of the sine graph, since we're going to be doing inverses, right? Arc sine is the same thing as inverse sine of x. If you see arc sine, that means inverse sine. We want the inverse to still be a function. We want the inverse to pass the vertical line test, that is, which means our original section that we look at needs to pass the horizontal line test, right? And if we look from 0 to 2 pi, or even negative 2 pi to 2 pi, we're definitely failing the horizontal line test, correct? So we only want to look at a section that passes that horizontal line test. We talked about this yesterday. And so for that reason, we're going to extend the sine graph a little bit to the left. And we're only going to look on the section from negative pi over 2 to positive pi over 2. Just this middle section right here. Because that's the only section that passes the horizontal line test. So that's the only section, if we invert it, that will be a function and will therefore pass the vertical line test. So when I I'm going to change up this table of values, and I'm going to start at negative pi over 2. And then negative pi over 3. And then negative pi over 4. And negative pi over 6 before I get back to 0. So that'll bring me through the fourth quadrant. And then the critical angles in the first quadrant are just pi over 6, pi over 4, pi over 3, and pi over 2. So again, this ties in with our unit circle, and that inverse sines only exist with negative pi over 2 to positive pi over 2 values. That whole limitation from negative pi over 2 to positive pi over 2 is directly linked to why we're looking at this graph only from negative pi over 2 to positive pi over 2. Okay? So, if we're filling in these values, I'll start with the sine of 0. The sine of 0 is 0. Sine of pi over 6. Well, pi over 6 is 30. What's the sine of 30? A half. That's the root 1 over 2. Then there's root 2 over 2, root 3 over 2, and 1. So if we go backwards into the fourth quadrant, negative pi over 6 is going to be just like pi over 6 was, except for it's going to be negative a half, negative root 2 over 2, negative root 3 over 2, and negative 1. So that's the section of the graph for an inverse function. You just flip-flop your x's and your y's. So negative pi over 2 as your x and y as your negative 1 is going to flip to being negative 1 and negative pi over 2. Can we just flip all those points and refill in? Okay, so I'm just going to go across my y's from here and throw them in my x over here. Negative root 3 over 2, negative root 2 over 2. And then a half. And then my x row becomes my y row. Good? So I just flipped all my points. So all I now have to do is graph these points. The issue that we're going to have to wrap our head around, it's not very difficult, is that you're scaling your axes kind of the opposite that you used to. Your x-axis always used to be your pi values, right? But because we flipped them, now our y-axis has to be scaled from negative pi over 2 to positive pi over 2. So I'm gonna make negative pi over 2 4 units out, down, and positive pi over 2 4 units up, because that's my min and that's my max. So negative pi over 4 is going to be halfway there, and positive pi over 4 is going to be halfway there up top. And my x-axis is what's being labeled with just negative 1 to positive 1. So again, I'll go out 4 to negative 1 and 4 to positive 1. And then I'm just going to plot the points. So an x-coordinate of negative 1 with a negative pi over 2 puts us here. That's the first point. Negative root 3 over 2 is approximately root 3 over 2. Negative 0.866. So there's negative 0.5. Negative 0.8 would be here-ish. Is that fair? Are we good with that? And pi over 3 would be where? Right, somewhere between pi over 4 and pi over 2. Do you have a question, Sarah? Like this one over here? Okay, is that better? Or did you like need another explanation of something? Oh. Gotcha. Okay. Then negative root 2 over 2 is negative 0.7, which is like maybe, well, this is negative 0.75, so negative 0.7 would be here-ish with negative pi over 4. And then negative 1/2 is going to be right there with negative pi over 6, which is, obviously from a degree standpoint, this is 45 degrees. This is 90 degrees. So 60's right about there and 30's right about there. So negative 1/2, negative 30 degrees. And then 0, 0. So far it looks like that. Good? Going out the other way, 1/2, which is right there, goes with 30 degrees. Again, maybe it's better if we label with radians, because when I show you in a minute on your calculator, this can only be done with radians. But just to give you a ballpark as to where these numbers are, this is 90 degrees, and this is 45, so 30 is going to be like right around there, pi over 6. So 1/2 paired with pi over 6. Root 2 over 2 again was 0.7, which is about there, paired with pi over 4. Root 3 over 2 is 0.866, which is there-ish, paired with a 60-degree angle, which is about here. And then 1 pairs with pi over 2. So it does that. You can see like the similar curvature to a sine graph. It's just kind of flipped. If we continued this any longer, this graph would wrap back around and we'd fail the vertical line test, right? And if this continued any longer, it would wrap back around, like look at it sideways. This would wrap back around and we'd fail the vertical line test. So we just look at that section of it. Okie doke? Okay? And then similarly on the cosine. I'm not going to go through this one, though, because the logic is exactly the same. I would change these points. The only thing I will review with you is what's the section of the cosine curve that passes the horizontal line test? No, because if I go to negative pi over 2, that's failing. What's the range of inverse cosine? 0 to pi. The reason for that is because that's the section right here. We don't have to extend it at all. That's the section that we're going to look at that passes the horizontal line test. So when we set up our table of values, we're going all the critical angles from 0 to pi. So that's 0, pi over 6, pi over 4, pi over 3, pi over 2. That takes us through the first quadrant. Then 2 pi over 3, 3 pi over 4, and 5 pi over 6 before we get to pi. Those are all the angles we'll look at the values of. Then we'll switch all those. Then we'll graph all those. Go ahead.
What's your next one at pi over 2?
Say again?
What's your next one at pi over 2?
2 pi over 3. So these are reference angles 30, 45, and 60 going through the first quadrant. and then we just back it up through the second.
And then minus pi over 3 pi over 4.
No, 2 pi over 3 is the, like, symmetrical to the pi over 3 version in the first quadrant. Pi over 4 in the first quadrant is like the 3 pi over 4 in the second quadrant. And then pi over 6 is like the 5 pi over 6 in the second quadrant. Well, for cosine, if you know you're inverting it, yes. Because cosine's inversions only are from 0 to pi. The sine inversions are from negative pi over 2 to pi over 2. You follow? Make sense? Okay. So, no, I would stay here just for like 2 more minutes. I am going to guess, I mean, when I teach this to my advanced pre-calc kids, I actually do this a whole lot slower. But I think, but I think the reason, and this is obviously Mrs. Fraser's pacing that I'm just stealing, I think the reason she goes through it faster is because you guys have your calculators. So, yeah, that's what I'm going to get to. So at the end of the day, and however, there's a bit that you need to understand so that you can use your calculator appropriately. So let's go to that. Let's go first to the inverse sine, or I'm sorry, the reciprocal sine. Where'd Ellie go? Oh, there she is. You don't need it. You guys could just watch, but if you want to do it yourself. So if you just blindly go and type in 1 over sine x, first of all, for the cosecant, there is no cosecant button. You all know that, right? There's no cosecant button, so you have to know to type in 1 over the sine of x anyway. If we all hit graph, we're probably going to have a large variety of pictures. Right. No, we're going back to the reciprocal ones. Okay, so here's issue number 1. Ryan still says R equals, so his calculator is in the polar world. So if that's your situation, hit mode. Hit mode and go where it says function, parametric, polar. Go to function. Okay? Now try to graph it, and some people still aren't going to have a right graph. That's okay. Okay, that's issue number 2. Anytime you're graphing trig on your calculator, it has to be in radian. So another mode situation, make sure you go to radian. Now, by the way, especially if you're borrowing one of my calculators, come your test, these might all be off because someone might have borrowed it and put it into something else in a different class of mine. So you need to know all this. Okay? Okay. Well, function. Okay. So, not only that, but, so once you're here, most of us are probably in a pretty good spot. However, no, you're still not Brock? This is what Brock sees. So let's troubleshoot. Y equals, that looks good. Mode, radian, function, so that's all good. So why does he still not see it? Well, we're going to talk about window next. Yes, you will. Well, Allie, let me tell you, if you can set up this from negative 2 pi to 2 pi, then you know your window should be set from negative 2 pi to 2 pi. So if we all hit our window button, a lot of your windows are going to be negative 10 to 10, which wasn't terrible, but it also, Brock's was probably from negative 1,000,000 to 1,000,000 because he couldn't see anything. He's like someone in an airplane trying to see someone swimming in a swimming pool 5 miles below. It just doesn't work. So when you do your x min and x max, just do negative 2 pi. You can type that in. As soon as I scroll down, it's going to turn that to a decimal, but who cares? Go negative 2 pi to 2 pi on that. Here's the other thing. Praise me. Okay, here's the other thing. Your scale. We don't want all of our little hash marks counting by ones. We typically count by pi, or you can even put hash marks at every pi over 2. So if you change your x scale, guys, stop and listen to this because you need to make sure your hash marks so that you can read points are done properly. Your x scale, do your hash marks by pi over 2. So there will be one at 0, there will be one at pi over 2. So, and then lastly, negative 10 to 10 is fine. But now,
X scale, what is it?
so do you see all my little hash marks? By setting x scale to pi over 2, I know that that's 1 pi over 2, that's 2 pi over 2, that's 3 pi over 2, and that's 4 pi over 2.
So I shouldn't have set my, I set my y's to 2 pi and negative 2 pi. Keep my x's.
Well, your y values are 0 to infinity, kind of, so negative 10 to 10 was fine there, because your y-axis is labeled with numbers still. Okay? Last thing. If you need to grab points from a table, you want to set up your table, so second window will do table set, and your table can start at 0, and your table can count by pi over 2 also, if you'd like, or pi over 4.
That looks good enough.
Because if I just look at my table right now, those numbers mean absolutely nothing to me. Because we would never be plugging in an x value of 1, an x value of 2. So you can make your table count by, let's just say, pi over 2. It's still going to show up when I look at my table. These are going to show up as decimals, but this is 1 pi over 2, which has a y coordinate of 1. This is 2 pi over 2, in other words, pi, which is why it's showing up as 3.14, with an error because there's an asymptote there. Did you follow? Yes? Okay. So, once you have your table set for this inverse function and your scaling all set up, the secant graph is going to be, you don't have to reset all that. So now for secant, if I just wanted just to confirm 1 over cosine, it's going to show me that appropriate graph. Yes? And still my table, when I look at it, it's going to show me errors where I have asymptotes at pi over 2. Pi is fine. Pi plots with negative 1. If you look at my graph, pi negative 1, and so on. Okay? Two pi is good. Why don't we write that here? On your reciprocal, because our inverses, there's going to be slight changes that we'll talk about. So on your reciprocal notes, write that your window should be the x window, negative 2 pi to 2 pi. And you can count by scale, x scale by pi over 2 is pretty safe. If you wanted to do a little bit more, you could do every pi over 4. And just because we know what happens with our y coordinates, they shoot up towards infinity and shoot down towards negative infinity, your y window can be negative 10 to 10 still. And you still, on your y's, you still want to count by 1s. You don't want to count by pi's on your y-axis because your x-axis is all in radians. Your y-axis is still regular numbers. Do you follow?
Yeah.
Okay? So x is your window's in terms of pi, and your scale's in terms of pi, and your y is still all in terms of numbers. Okay? Now, when we do inverse functions, my x window should not be in terms of pi anymore. I flipped everything, right? So my x window should be from -1 to 1. And I can count by 0.5s or 0.25s, I don't really care, but make sure you're counting by numbers. I'll do 0.25. Your Y window in this case, though, does have to be between negative, well, it's going to be different for inverse sine versus inverse cosine. Your Y's for inverse sine should be negative. I mean, if you went further, you'd be fine, I think. I'm going to have to play with that. Let me do this quickly. So on your window, and I'm about to type in inverse sine, for my x-axis, I'm definitely going to go from -1 to 1, and I'm going to count by 0.25. My y, just because I already have done it by hand, I'm going to go from -pi/2 to +pi/2, and I'm going to count by pi/4 just for fun. So if I graph y equals inverse sine, I do have an inverse button. You know that, right? Inverse sine is the blue functionality above the sine. So if I do inverse sine of x, I should get that same graph. My question is, what if I do, well, I can't plug in anything. Like if I ever did like -pi to pi on my y-axis, so if I went back to my y scale and I did -pi to +pi, I don't think that's going to create any issues. It's just going to stop earlier. For inverse sine, it could be -pi/2 to pi/2. That's what you need to see the whole thing for inverse sine. But for inverse cosine, you don't go -pi/2 to pi/2. You go 0 to pi. Right? Because if you look at your x coordinates that we look at, those are going to become your y coordinates. So they're just 0 to pi, not negative. But I kind of increased this negative, for the inverse sine one that we're looking at right now, I increased the -pi/2 to +pi/2 to -pi to pi, just for the sake of seeing if it screwed anything up. It doesn't. The graph just stops. So if you want it to be the same for both, you can just go -pi to pi. That'll cover everything for both of these. So for the inverse cosine, again, my window, my x is from -1 to 1, scaling that, and my y coordinates are now with the pi's. So my x's of the original, I'm looking from 0 to pi because it passes the horizontal line test. So my y's will be what's from 0 to pi. And I can count by pi/4 and graph. Yeah. I only went on my y-axis from 0 to pi. That's why I'm not seeing below, because it would stop anyway. It's just completely above, if you want to sketch that. And that passes the vertical line test. Agreed? That's because we chose a section to invert that passed the horizontal in order to make that happen. Your calculator won't graph something anyway that fails the vertical line test. So, I think that's why she did this so fast, because you cannot, like, conceptually, you need to understand the flip-flopping of the points for inverses, and you need to understand reciprocating your y values and kind of why that all happens. But at the end of the day, you do have your calculators. Okay? So if you're just reciprocating, keep your x-axis in terms of pi, your y-axis in terms of numbers. If you're inverting, you've got to flip-flop that. Your y-axis is what's in terms of pi, and your x-axis is in terms of numbers. You have to understand the concepts to know how to use your calculator. Otherwise, you'll be guessing and checking with no idea and just praying that something comes up, which you might do anyway, but at least I've explained.